We are on the last section of this unit, our second unit for comparing distributions. Some vocabulary terms. The parallel box plot is also referred to as a double box plot, and it's kind of exactly what you would think, plotting two box plots on the same number line to compare them. Okay, and we'll see in a second what that looks like. We also have double, or also known as back-to-back stem plots. And again, it's kind of what you would think. It uses one stem with one data set on the left and then another data set on the right. So essentially it's two stem plots put together. And again, we'll see what those look like in a second. To compare distributions, that's what we're doing here. We're talking about comparing distributions. We use this little acronym SOCS to help us. So SOCS. Yeah, I know that's not really how you spell these kind of socks, but look at how cool those math socks are there. That'll help you remember all the different points that you need to talk about when you're comparing distributions. So both of these things that we're looking at, the double box plots. So the four things we will need to talk about, the SOC and the S. Oh yeah, I paused. Somebody had come in. What I was going to say is you are talking about two different data sets each time. So the double box plot, a double stem plot, it's two different pieces of data, but we're going to do them on the same either box plot or the same stem plot. So we're going to compare the numbers. So that's what we're talking about here, is comparing all of these things. First thing you're going to want to do, fill this in, pause as needed. Compare the shape of each distribution. So our first S stands for shape. When we're talking about shape, usually we're talking about, is it skewed? Is it symmetric? That gives you the shape of it. O, determine if there are any possible outliers. Two things on outliers. One, at the beginning of this unit, a lot of you weren't knowing what it was. So hopefully you've got it now. It's a data point that's really far removed from all the other data points. So maybe all your data is between 10 and 20, and then you've got one number that's 75. That's an outlier. Also, notice how I'm saying that, outlier. Some of you guys are saying outlier. Outlier. C stands for center. Compare the center of the distributions. And center usually is talking about median. Median is your middle, your center of it. And finally, the last S is the spread of the data. And usually we're talking about range there. So you might want to note a couple extra terms in there. Shape, whoops, what am I writing? Shape is usually the skew or symmetry. Hopefully you already know what the outlier is. Center is usually the median, and the spread is the range. Okay? So maybe you're like, well, why didn't we call it a SOMR? SOMR? I don't know. You can if you want. This is just meant to help you talk about the things. You're going to need to hit every single one of these points when we compare the distributions. All right, so this example is a parallel box plot. Obviously, there are two box plots. We say parallel because they are parallel to one another. Also, you can call them a double box plot, obviously, because there are two. So we're comparing the Chicago Bulls and the Toronto Raptors from the 97-98 season. This is going back to the Michael Jordan era. And we want to compare the two distributions. Little acronym over here to remind you to hit all of your points. So the first thing we want to talk about is the first S, which is, if you don't remember, look back. I got to click it again. It's the shape. Okay, so looking at the shape of this, we're really looking at the skew, the skew or the symmetry of it. So if you look at this top one, the Bulls one, is that symmetrical? Skewed left, skewed right? Well, I'd say the Bulls, that's skewed right, right? Okay, most of your data is here on the left side. 75% is here, and then this 25% skews way out. Okay, for the Raptors, I'd say that's pretty symmetrical. Okay, and I'm just making notes over here before I write myself a nice, neat paragraph about it. Outliers. With a box plot, it's not always super easy to find outliers. So the way this is written, you might think, well, maybe this is an outlier right here. But if you had, maybe you have 20, we know on a box plot, 25% of our data, 25% of our data, 25%, and then this big long line's 25%. But maybe we have, um, maybe there's 100 pieces of data total, so we would have 25 pieces of data in this range. Maybe there's all 25 are over there, okay? And maybe there aren't any here. Those wouldn't be outliers then. So for here, we don't have enough information, and you don't have enough for either one of them. Okay, box plots are generally very hard to find the outliers. The center, well, the center of the bulls is about maybe a little bit more than 400. Median is about 400, whereas for the raptors, it's more like maybe 625. Median is 625. So we would want to talk about the fact that the raptors median is higher than the bulls median. The center of the raptors data is higher than the bulls. And then finally, the last S, if you forget what it is, you can always come back. It's the spread. Okay, so that's basically how spread out there. Now it's very clear here the bulls have more spread out data than the raptors, so you would want to say that, and then you could actually give the specific approximate range. So if you take the bulls range, it's something like, oh, maybe 2350 minus maybe 150. Figure out what that is. And then the raptors, maybe you've got about 1300 minus 150. Okay, you can see their minimums are pretty close, but the bull's maximum is so much higher, so you get a much more spread out range. All right, so let me show you the paragraph I typed up for all this. The distribution of points. So distribution of points is talking about the spread. Okay, so I didn't start with my shape when I started writing. It doesn't matter. You can do these in any order. It does not have to be in the SOX order. You just have to make sure you hit them all. So if you want to start by talking about outliers, you want to start by talking about center, you can start with any one of these four. You can do them in any order. You just have to make sure at some point you get all of them. So I started with the spread. The distribution of points scored by the bulls appears to be skewed. Oh my gosh, I'm lying to you. I didn't start with that. I just didn't finish reading what I wrote. I did start with the very first S. I started with the skew. Appears to be skewed to the right, while the distribution of scoring is more symmetric for the raptors. Okay, I gave a full and complete sentence. I missed the period, and that is exactly what you need to do. Okay, I don't want, like, these are just little notes as I was explaining what we looked at, but when you are giving your comparison, full sentences. Okay, and they need to actually compare one to the other. Next, we cannot tell if there are any outliers, and you don't need to explain that. We know that it's hard for box plots. The median number of points, so here we're talking about the center. The median number of points scored is higher for the raptors, roughly 620, than it is for the bulls, about 410. Okay, so a little different from what I said, but in the same ballpark, that's fine. And then lastly, the bulls distribution has a greater variation because it is more spread out. The bulls range is about 2270, while the raptors range is 1200. So I hit all four of my points. I hit my S, my O, my C, and my S, and I used complete sentences, and that is what I expect from you. Okay, compare one to the other. Of course, pause as needed here to finish writing that down. Okay, now we have, whoops, I got my answer up there already. Let's cover that up. Compare the pulse rates in beats per minute of Algebra 1 students before and after taking the 2.5 mastery check. If you remember that 2.5 one, whew, it was a rough one. Some of you guys ended up like super nailing it and getting it down really good by the end. If you remember, that was the one where you were solving equations where they were all variables, no numbers. I'm sure some of you remember that. So picked a good one here. So pulse rates before they took the test and then after they took the test. We have a key here. This is not on your paper, so you probably want to jot this down. So look at what this looks like. Your stem is actually in the middle. This part right here is your stem. And then on each side, you have leaves. Okay, so you have to use this middle number with both sides of data. So 0 bar 1 bar 8 represents 110 before. So look at what you actually have to do. You have to take your 11 and then put your 0 on the end of it, and 118 after. So the right side of it, so if you ignored this left side, the right side's a normal stem plot, nothing crazy at all. But the stuff on the left side, you have to almost read backwards. So 68, 68, 68, 69, 70, 71, 71, 74. Hopefully you're seeing this. So down here you would have 90 and 96, 104, 110. Okay? Take a look at the 13 stem. You don't have a leaf on either side. That means there was no data that has 130 anything beats per minute. Okay, so not before or after. But we had to have that there because we do have something that has 146. And if we wouldn't have put this 13 here, it would have looked different because this would have slid up and your distribution wouldn't, the shape of it would have changed. So we need that 13 in there just to hold that spot open, just as a placeholder. Okay? All right, so looking at this double stem plot or back-to-back stem plot, we want to compare the distributions. So we need to talk about the shape. So if I'm looking at the shape here, well, let's start with the after. If I'm looking at after, I can see here, this part here looks pretty symmetrical, but then it goes out this way. Okay, and we kind of want to, let me see if I can draw a line and show you which way I want to flip it. Which you guys have done this before with the regular ones. So when you're looking at this, you want to have like a number line. Normally we're thinking about things vertically. And obviously we would want a 6 here and 14 to be here. I'm talking about the stems here. So you would need to take this and think of it as coming down this way. So if in your head you can take this shape here, and you need to think about taking it that way, to a horizontal way. And if you look at it that way, then it's pretty easy to see that it looks to me like it's skewed right. Okay? On this one, it's the same type of idea, but think about which way it needs to be rotated. Again, here's your 6, here's your 14. So if you need your 6 to start on the left, you actually have to take that, I'm going to move this shape over just so I can move it, and rotate it this way again. But that's kind of like, oh, okay, I don't know, that's weird. Let's see if I can flip it. Nope, it's not going to work. I need to like mirror image it. Let me see if I can do it real quick. Okay, so I did it, but I'm not sure that it'll help you the way I did it. So what you have to imagine is kind of like, okay, I have these 4, then I have this, then this, then this. So you do want to flip it, putting your 6 first. Maybe I should just stick with that. Okay, so I had this, and then if you imagine just rotating it. No, I think I'm just going to confuse you. Anyway, so let me do it without actually showing that. So just thinking it through, you have more this way, right? Okay, now imagine those kind of hanging down off of this. If you rotate it, they'd be hanging down. And you could see that you have more data here than you do this way. So hopefully you can see that that would be skewed right. If you need more explanation, come over and see me and I can draw you a picture a little better with explanation than I can on this on my little pad here. Okay? All right, so we're thinking that maybe both of them are skewed right. So that was our shape. Our outliers, we might have an outlier here at 146. That's not super far away from this data. So you could say maybe that's an outlier. You don't always have to say definitively about outliers because it kind of depends on how you're going to define it. Now, obviously, if we had maybe like 212 as one of our pieces of data and everything else was here, that would definitely be an outlier. That's very far out. But it depends on how, for 146, it depends on how far away you want to determine that that's an outlier. Your center. Well, how would you find the center? So we could type this all into our calculator and find the median, but I think it's just as easy to do this one without any assistance. So I kind of just like to do the cross-off method. A lot of times I know I've seen a lot of you guys doing that. So if I cross off 4 from this side, 4 from that side, and I'm just picking 4 just because that was how many were there. And then be careful, I went 4 from the high side, now I need 4 from the low side, which is not 78, it'd be 70. Okay, and then one more. Looks like my median right here is 76. 76 median. Over here, I'm going to do that same thing. 4 was a good number for me. 1, 2, 3, 4. Here I'm going to do 3. I need 3 from that was 3 from the high side. 3 from the low side then would be there. 1, 2, 1, 2 there. And I end up with 98 for my median there. So I could talk about the center of the pulse rate after is higher, its median is 98, versus the center, the median before is 76. And then lastly, I need my spread being the range. So here I have my minimum is 68 before, and my maximum is 110, so I could subtract those. And then after I have 86 as my minimum and my max being 146. Subtract those, compare those numbers. So here is my paragraph that I wrote. The distribution of pulse rate, that's your spread, is higher after the mastery check, median being 98, when compared with before, median being 76. Okay, so I kind of talked about a few things in there. The range for after, I don't know why that is there, is also greater when compared with before. And the pulse rate after may have an outlier at 146. Maybe it does, maybe it doesn't. Both distributions appear to be skewed to the right. So did I hit everything? Did I talk about the shape? Yep, that's the skew. Did I talk about the outlier? Sure did. Did I talk about the center? Yep, I see some median work here. And did I talk about the spread? Yep, I talked about the range. Okay, so you guys should be doing something just like this, complete sentences, making sure you hit all 4 of those pieces. All right, last problem in our notes here. Everyone knows that Bean loves his scooter. Russ wants to know if Bean drives his scooter faster on the way to work or on the way home from work. He decided to record his speed several times over the next month. Here are his results. Create a double stem plot and parallel box plots. Use your calculator to help you. Decide which plot display is the best for this data, then compare the distributions. So what work are you going to be doing in your calculator? Well, we know how to find our 5-number summary from the last section, and hopefully you even know how to make a box plot in there. I don't expect you or need you to do the box plot in your calculator, but I do think it is helpful to find the 5-number summary in there. It's a little quicker than doing it by hand. You should still be able to do it by hand, but again, I just think it's a little quicker in there. So pause the video now and go ahead and do this. Remember, you are doing a double stem plot and a parallel box plot. I want both of those done, and then your comparison. Okay, hopefully you actually paused the video and you did this work on your own, but I'm going to walk you through different pieces of it. So on this problem, I would have used my calculator to put the numbers in and order them and then find the 5-number summary. So the way I would like to do that is under your home screen, so press home to get there, then a new document, and you probably already have something in there, so you want to click no that you don't want to save it, and then start the new document. At that point, you want to choose 4, add lists, and spreadsheet. I'm going to name my first list, and I'm going to name it just A, first list being A, so my to work information will be A. And then I'm just going to type all my numbers in. When you type these in, double check, make sure you're not missing anything, make sure you're hitting all of it. So I don't want to accidentally type 4 when I really mean 45. So watch as you're doing it. Make sure you're hitting everything, because obviously just typing in even one number wrong is going to change all of your information. Okay, and then I'm going to go to the B column and I'm going to type my second set and I'm going to just call that one B. Okay, so I have both lists in. Make sure you have the right number of data pieces in there. So my second list had 20, my first list had 19. Make sure that is correct. It is. Okay, so now what I want to do is I want to sort these, because if they're not sorted, if they're sorted, it's going to make it easier to look at everything. So I could go to Control, Add Page, which is really Control Doc, and I want to add a calculator page. And then I want to sort it. So Menu, Statistics, List Operations, and I want to sort ascending. Now I have to tell, this means sort A just means sort ascending, and then I need to tell it what list I want to sort. Well, I want to sort list A. But I also want to sort list B. So then I press Menu, Statistics, List Operations, Sort Ascending, and now I want to sort list B. On the left side of your notes here, there is a spot for you to write down steps from the calculator. I expect you to do that. I'm not always going to list out the steps for you. I'm telling you what steps to do, but I'm not writing out the steps myself. That's for you to do. So you need to come up with that list of steps yourself so that you know how to work this calculator. Okay, so now if I just type in A, it's going to give me my list back in ascending order. Same thing if I type list B. Okay, from this I'm going to make my stem plot and my box plot. Okay, so I'm going to do that real quick, show you what mine look like. Okay, so I used that data in order from my calculator to come up with my double stem plot. I wrote a key in, don't forget your key, and I have all of my data in here. Next thing I'm going to do is use my calculator to find my 5-number summary and do my box plot. If you have not done that yet, do it now. Menu, Statistics, List Math, rewind. Let's start that over. I'm doing my 5-number summary. It's Menu, Statistics, Stat Calculations, and I still want one variable statistics. I'm going to do just each one individually. So first for list A, there's my information. Okay, there's my 5-number summary. Okay, I'm just going to push this over here so I have it to use. And then I'm going to do the same thing. So Menu, Statistics, Stat Calculations, one variable statistics, still one list, but now I want to do it with list B, or whatever you might have named it. And again, there it is. Okay, so go make your box plot if you still have not done so. Okay, here's my box plot. I labeled which one was from work, which one was to work. And then the last thing I need to do is compare the distributions. So, let's see. Dropping things here. If you have not done that yet, please go and do full sentences comparing your distribution. Hit SOCS, hit all of your points. Okay, here's what I have. The shape of the distribution from work is symmetric, while the shape of the distribution to work is skewed right. There doesn't appear to be any outliers, and it's easy to see, or more easily to tell from the stem plot than the box plot. 63, maybe I should have said 63 might be an outlier. Let's say that. 63 may be an outlier. I'm changing my answer here. To work. Let me see. In the to work data, there does not appear to be one on the other, on the from work. The median speed to work is slightly higher than from work, just a little bit higher than the from work. The spread, and I gave the actual numbers, the spread of the data to work is higher than from work. So obviously this purple box plot is more spread out than the red one. And again, I gave numbers for my range. So check to make sure you covered all your bases, your S, your O, your C, and your S again. And complete sentences. Should look nice and neat, easy to read, no big deal. Lastly, they had asked us which plot display you think is best for this data. I would say the box plot is better in this case because you have so many for your 4 stem, so many leaves on your 4 stem. I don't know that that's the best way to display that. So in this case, I think box plot. I don't always think that. It depends on your data and what it looks like. So that's an opinion too. Maybe you like it better this way. All right, I know that's a lot to do for one problem. That took a long time, but you don't have that many to do on your assignment. Okay, it's a pretty short one this time. All right, have fun.